Good day, everyone. I'm Mr. Joseph, your chemistry teacher. So, still on mole concept. Um, this lecture is a continuation of our previous, lecture. In our previous lesson, we were able to uh, express the relationship between mole and relative atomic mass and relative molecular mass of compounds and relative atomic masses of elements. We're able to relate mole to the Avogadro's number of particles. We say a mole is the standard unit of amount. It is the substance that contains the Avogadro's number of particles. So at this point, we want to state the relationship between mole and relative atomic masses of elements and relative molecular masses of compounds and the volume of gases. One mole of any gas, one mole of any gas occupies a volume of 24 dm cube, and one mole of any gas is the relative atomic mass of that gas, relative atomic mass, or what? Or the relative molecular mass of the gas. So be it an element or a compound. So one mole will occupy a volume of what? 24 dm cube. So for example, one mole of hydrogen gas will occupy a volume of what? 24 dm cube, which is equivalent to the molar mass, which is 2 grams of what? Hydrogen gas will occupy a volume of 24 dm cube. So with this expression, we can state the relation between mole, volume, and mass. One mole of ammonia gas will occupy a volume of 24 dm cube. That means 17 grams of ammonia will also occupy a volume of 24 dm cube at what? At RTP. That is at room temperature and pressure. So this value is what we call the molar volume of gases. That is the volume occupied by one mole of any gas. Now, let's move on. So the calculation before us will give us an expression of what? Moles, masses, and what? Volume of gases. Now, for example, let's solve this question. Sodium peroxide is used to absorb carbon dioxide from the atmosphere and release oxygen in closed environments such as spacious capsules and submarines. From the equation, 2 moles of sodium peroxide react with 2 moles of carbon dioxide to produce 2 moles of sodium carbonate and oxygen gas. We are now asked which mass of sodium peroxide will be required to remove 2.4 dm cube of carbon dioxide from the atmosphere at RTP, at room temperature and pressure. And that is what RTP means. It means room temperature and pressure. Now, we'll be taking two approaches to this problem. The first thing we are going to do is we'll look at the equation whether it is balanced, and from all indication, the equation is balanced. So the next thing we'll focus on what we're asked to calculate. From the question, what mass of sodium peroxide will be required to remove 2.4 dm? So we are dealing with sodium peroxide and what? Carbon dioxide gas. Now, the first thing we'll do, we're going to calculate the mass of 2 moles of sodium peroxide. So that will be 2 times what? The molar mass of sodium peroxide, which is the mass of 1 mole of sodium peroxide. Sodium, from our periodic table, the relative atomic mass of sodium is 23, so it will be 2 times 23 plus the relative atomic mass of oxygen is 16, which will be 2 times what? 16, will be required to remove 2 moles of carbon dioxide gas. And 1 mole of carbon dioxide gas occupy a volume of 24 dmq. So 2 moles of carbon dioxide is going to occupy a volume of what? 2 times what? 24 dmq of what? Carbon dioxide gas. So we have to calculate the mass of 2 moles of sodium peroxide, which will be 2 times 23, which is 46, plus 2 times 16, which is 32, then multiply by 2. So that means we have 156 grams of sodium peroxide. Will be required to remove what? 48 dmq of what? Carbon dioxide. So we're asked to calculate the mass of sodium peroxide that will be required to remove 2.4 dm³ of carbon dioxide. That means 2.4 dm³ of carbon dioxide will be removed by what? What mass of sodium peroxide? 2.4 dm³ of carbon dioxide will be removed by what mass of sodium peroxide? So you cross multiply. Call it x. So x now, just do simple proportion. It will now be what? 2.4 times 156 divided by 48 times 2.4 divided by 48. So the mass will be what? 7.8 grams of what? Sodium peroxide. So the answer to this question is what? C, the correct answer. As simple as ABC. Just straight to the point. From the expression we have on the screen, we just relate what? The mass to the volume. So this is not the only approach. There's another approach to this. But if you are comfortable with this approach, you are free to use it. You arrive at the same answer at the end of the day. The most important thing is for you to get the correct answer. So just focus on what you are supposed to focus on. Then you get the right answer without wasting much time. Now let's go to the next approach. Please, I want you to listen attentively so that you can get it right. If you're not comfortable with this approach, there's another approach you can use to solve this particular problem. Now, from our previous class, we were made to understand that there's a relationship between the number of moles, the mass, and the molar mass. The molar mass is the mass of 1 mole of a substance. It can be an element or a compound. So number of mole is equal to what? Mass over what? Over molar mass. So the mass will be equal to number of mole times what? Molar mass. So we can just make each of them the subject of the formula. Now, remember I told you that 1 mole of any gas will occupy a volume of what? 24 dmq for dmq at what? At RTB, that is at room temperature and what? Pressure. Then you are asked to calculate which mass of sodium peroxide will be required to remove 2.4 dmq of carbon dioxide from the atmosphere at room temperature and what pressure. Now, 1 mole of carbon dioxide will occupy a volume of 24 dm3. Therefore, 2 moles of carbon dioxide will occupy a volume of x. So we'll cross multiply. That means 2 moles of carbon dioxide will occupy a volume of 2 times 24 over 1. So which is 48 dm3 of carbon dioxide. So 2 moles of carbon dioxide occupy a volume of 48 dm3. So we are asked to calculate what mass of sodium peroxide will be required to remove 2.4 dm3 of carbon dioxide. What mass will be required to remove 2.4 dm3 of carbon dioxide? So since we've established the fact that 2 moles of carbon dioxide will occupy a volume of 48 dm3, that means from our equation, 48 dm3 of sodium peroxide, carbon dioxide requires 2 moles of sodium peroxide to be removed. Therefore, 2.4 dm3 of carbon dioxide will require what moles of sodium peroxide? So we'll put x here. Simple proportion will cross multiply. So it will now be 2.4 times what? 2 divided by 48. So use my calculator. 2.4 times 2 divided by 48. So you get 0.1 moles of what? Sodium peroxide. So to remove 2.4 dm3 of carbon dioxide, you need 0.1 mole of sodium peroxide. So going by the formula, number of mole is equal to mass over molar mass. So we'll cross multiply. So the mass now will be equal to what? Number of mole times what? Molar mass. So to get the mass of sodium peroxide, that will be required to remove 2.4 dm3 carbon dioxide. The mass now will be equal to number of mole of sodium peroxide is 0.1 multiplied by the molar mass of sodium peroxide. That is the mass of 1 mole of sodium peroxide, which is 2 bracket 23 plus 2 bracket 16, which is 46 plus 32 is equal to 78. So multiply by 78. So the mass of sodium peroxide now will be equal to 7.8 gram. So the answer to this question is what? C. So irrespective of the method, irrespective of approach, you will still arrive at the same answer. So you can manipulate it in different form, in different ways. At the end of the day, you still arrive at the same answer. So feel free to use any method you are comfortable with. If the first method is difficult for you, you can use the second method. It's as simple as ABC. So please, I want you to solve as many questions as possible. And I'm going to give one particular question as assignment, and feel free to solve as many questions as possible. Use any method you're comfortable with. And if you're having any difficulty, please feel free to contact me. I'll always be there to answer you. I'll always be there to respond. You can go to the comment section and comment. If you have any challenge, just feel free to contact me. So let me give you the assignment just to keep you busy. And after that, you can look for similar questions, even questions that are tougher than this, that are more difficult than this, and apply the principle. Make sure you read the question, understand the concept, and know what you're asked to calculate. And it's as simple as what? ABC. So this is More Concept Season 3. It's a continuation. So let me give you the assignment. Please make sure you attempt it and attempt other questions. So this is the assignment. Sodium azide decomposes as shown. You can see the equation. With volume of nitrogen, measure that room temperature and pressure will be produced by the decomposition of 150 grams of sodium azide. So this is the assignment. Attempt it and get in touch with me. Thank you very much. Feel free to contact me. Feel free to talk to me whenever you have any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. Have a nice day.